Welcome to the session on Connected Mobility Solution. Connected Mobility Solution is a platform which is developed in partnership with AWS, where Capgemini and AWS has worked together as strategic partner for automotive domain. It provides various kinds of use cases and accelerator to adopt for automotive industries in areas of product innovation, in areas of in-vehicle personalization with connected vehicles and mobility. It also provides features which helps in customer engagement on it using digital technologies, and also enhances telemetry and analytics related information on the platform, which helps us build feature use cases for the organizations. If you go to the next slide, please, Abra. So what does Connected Mobility Solution as a platform provides? There are various use cases that we are going to demo here, which is going to help and understand the whole life cycle and management of vehicles, right from onboarding a vehicle on the platform, doing its registration, activation, able to connect to the telematics information within the TC unit of the vehicle and drive that information, and then use that information to do some industry-leading use cases, for example, anomaly detection, where we can find out whether there is an anomaly. For example, there is a oil temperature that is higher than a specified limit, and that can be detected as an anomaly and that can be displayed. There are various diagnostic alerts that can be configured. If we are operating and we are a large fleet provider, we can also look at behavior of the drivers and customize that whole workflow to get real-time notifications. Things that we can also do is also do a trip identification from location A to location B. It helps to understand how many trips the vehicle has taken and what kind of telematics information, including tracking on the live map UI. So all those and more that is integrated as part of this platform. On the piece of hardware integration, it does helps us to understand that how do you register the TCU unit with the platform, have IoT configurations, do certificate rotations, and software OTA, and how can that be leveraged to build features and use cases for the industry. So if you look at what are the three key areas of features that are provided as part of the Connected Mobility Solution platform. If you look at vehicle, there is platform about provides fleet provisioning use cases, right from, as I said, you can onboard a vehicle or a group of vehicles via API and services. Then there is activation of those vehicles. Then you can associate identification and have ownership details being registered for the vehicle. And we are going to look some of these as part of the demo that we are going to show. Obviously, we'll look at all the telematics information and the events that I spoke about, for example, related to anomaly or trip detection services, and how the telemetry information is configured, stored, and leveraged to provide intelligence as part of this platform. There are also services that we're going to look at. For example, the whole UI configuration helps to view the data and also provide details for owner as well as maintenance providers. So let's look at all these use cases and services. And this is all built on using managed services on AWS. And we leverage all the best practices of an AWS well-architected framework that has been already provided us from the cloud provider. Abra?
Thank you, Rahul. So as Rahul mentioned, let's start over. Before we go on to the deep dive onto the demo, if you could just spend a couple of minutes on each of these. So secure data consumption means the vehicle, we install the Greengrass IoT software on the vehicle's TCU unit, and that interfaces with the vehicle and collects all the data, telemetrics data, and that sends those data to the IoT cloud. And that entire communication happens securely in transit. And the second option is driver behavior, where based on the telematics data that is sent constantly from the vehicle to IoT cloud, we can calculate how the driver is handling the vehicle, how many brakes, what are the accelerations, and based on those, we can run analytics and figure out if there can be an improvement on the driver's score. Third is, as Rahul mentioned, anomaly detection, where right now we have configured oil temperature detection, where we are using specific algorithms like random cut forest algorithm to determine what oil temperature, if the oil temperature is below or above, so we can detect an anomaly and push that notification. And diagnostic alerts, various diagnostics about the brakings, engine diagnostics, all those diagnostics also data are also sent back to the IoT cloud from the vehicle over secured channel. And based on that, we can create diagnostic alerts and see that per vehicle. And the last one is location-based services, where, as Rahul mentioned, we can see all the vehicle trip-related data started from and destination, how many miles, and other related details. So once we start about provisioning and lifecycle management, so we will go and see how we can onboard a new vehicle, and onboarding means how we can connect that vehicle to the IoT cloud. In terms of each vehicle, we'll have a certificate, unique certificate for identification and authentication and authorization. So using that certificate ID, the vehicle's VIN number will be associated in IoT cloud. And the additional things we have is the OTA software update. So this update can also be done through MQTT. And the last one is the fleet UI, and the fleet UI is the place where we can see all the onboarded vehicles and all the related data, like anomaly data, diagnostic data, and everything, and trip related data can be seen. So let me quickly go through the next slide. So in this slide, let's go ahead with the first one, which is Fleet Manager. I'll open that screen right now. Okay, so this is the Fleet Management UI. This is the URL we have right now. And this Fleet Management UI shows the global map. And all the circles, the bubbles, are the vehicles. So we can see 1K vehicles here and 100 vehicles over here. And now if we focus on the tabs here, we have anomalies. So anomalies is the oil temperature. So right now it shows 61 vehicles reported oil temperature anomaly. We can filter those vehicles by clicking and doing a save, which should load all those 61 vehicles on the right hand side. So right hand side dashboard, on the right hand side, it shows all the vehicles. So we are displaying the VIN number type and the software version used on that vehicle. So if you go inside, right, so it shows the vehicle VIN number, and along with that, it displays the software version, the trouble code. Trouble code is the diagnostic alerts, cylinder misfire, cylinder 1 misfire, and the current speed, the fuel level, odometer reading, oil temperature, and battery charge status. And at the bottom, we have schedule and OTA. And the next tab is trips, where we see trip related data. So each trip has a start and an end, and based on that, we calculate the trip data. So when the trip started, start time, the duration, and the distance in miles covered, and average miles per gallon. And once you click on that, it shows you the entire trip with the related data in that pop-up. The next step is video events. In video events, you will be, right now we have a video that we have uploaded here, and that video shows events video are transmitted from the vehicle to IoT cloud. Okay. So each vehicle that we see here has these details on spread over the 3 tabs. Okay, now going back to the main screen and the main screen options. So basically, let's clear out the filter of anomalies. So it loads all the 1,307 vehicles that we have currently onboarded into CMS. The next one is trouble code, and it lists down all the trouble codes that are currently notified or sent by the vehicles. So we can again do a filter and save, and it'll load all the vehicles related to that trouble code. And again, once you drill down into the vehicle, you'll be able to see the trouble code in the details page. So it says engine oil pressure sensor. Okay. Save. Back. The next tab is location, where we can filter out based on a particular city, state, or country. And the next to it is searching a vehicle by VIN number, make, model, year. This will be going over this when we start go to the next stage of this demo. And software is used for the software version to search based on the software version. Okay, so this is overall a brief about the fleet management UI, where you can see your entire fleet and you can do various types of you can apply various types of filters to drill down on each group or individuals to see what problems or what data they're reporting back to IoT Cloud. Okay, so next we are going to look at how to onboard a vehicle. So onboarding vehicles, this is an API walkthrough. This is a very quick API walkthrough where we execute the 5 different APIs, REST APIs. These REST APIs are currently hosted on Amazon API Gateway, which behind the scene talks to Lambda, and Lambda talks to DynamoDB and Elasticsearch and various other things. So the first option is to create a supplier and then create a user, register the device, which is the vehicle. We registered the vehicle with the certificate, initially with the certificate ID. To each vehicle will have a unique certificate installed on that. And using the certificate ID, you will be registering the device. Next is we activate the device based on the VIN number and some other details. I'll be showing that. And the last option is associate the user with the car. Okay. So for this demo, we'll be using Postman. So the first thing that we need is the Cognito ID token. So for security purpose, we have this ID token enabled, and this ID token expires every 15 minutes. So let me grab that. And here are the environment variables that we are using for this demo. Let me update the ID token. Okay. Apart from that, if there are all other different sections or variables. So this one, I'm going to update the device maker name. It's a new device maker, and external IDs to identify the device. So this will be uniquely identify the device, and this is the VIN number. We are going to use a VIN number that doesn't exist as of now. And this is the username, this is the first name, and this is the last name. So this user will be associated with the vehicle. I think we're all set. Let me save it. So these are the 5 APIs that we spoke about. So before we start that, let's quickly verify if the vehicle VIN number currently exists or not. It should not. Okay, it shows 0 vehicle here on my fleet. Okay. All right. So we're going to create a supplier with the provider supplier name. Okay, it created the supplier name, and all the other details are coming from the environment variables that we have set. And then next is creating user with the specified username and first name, last name. The next one is register a device based on a certificate ID. Okay. And the next step is to activate the device that we have created. And this payload takes a lot of details like model, make, year, and we are going to replace the VIN number that we have selected. Send. And finally associate the user with this vehicle. So this is the process of onboarding a single vehicle. So if we go back right now and refresh the page, we are not going to see the vehicle because the vehicle has been onboarded, but no data has flown from the vehicle to the IoT cloud. So for that, we will use MQTT client. So the communication from the vehicle to IoT cloud is done through topics. So there is a publisher and there is a subscriber. So in this case, the publisher is the vehicle and the subscriber is IoT cloud, and it's possible the other way around as well. So the vehicle payload, if I open up the payload here, so the payload contains a bunch of fields, attributes, and the most important thing, it contains the VIN number and the message ID, unique ID, geolocation, location, and all the other related details, speed, readings, fuel temperature, oil temperature, fuel, oil temperature, and other details. So let me copy this. Okay. So let me use this one, and this is the name of the topic. So each vehicle sends data to a unique topic, and the topic because it's unique because each topic has the VIN number associated embedded in the topic name. So that way each vehicle sends data to its own topic. Okay. So I have published a couple of messages. Let's go back and see if we are able to view the vehicle. Okay, so right now we are able to see the vehicle here. And whatever data we have supplied is showing in the UI. So let me quickly change one of the fields attribute. Let me make it bigger. Yeah. So let's change the battery percentage to 55%. Okay, so we can see the battery changed to 55%. That completes our vehicle onboarding section. Let me clear the filter so that we're able to see all the onboarded vehicles. Okay. The next item on our demo is to run a simulation. So basically, we create a simulation where we create a bunch of like cars, vehicles, and we start the simulation where it shows how they move around on the map. To run the simulation, I just want to verify if the previous simulation is still running. Yeah, the previous simulation is still running. So this simulation is we have created the simulation in Arizona. So if we look at the simulation payload, it takes something called simulation ID. So first we create a simulation where, just to give you an idea, where we specify the range of latitude and longitude. So, and we specify the number of vehicles. So in that lat and long, it will create 5 vehicles, and it will create an ID, and based on the ID, we will be running the simulation. Okay, so right. So as we can see, the vehicle is moving, but moving is moving on the map. Let me see if you can just if the more close you get to it. Okay, I think, yeah, so we just have to keep following the vehicle. The simulation takes a little bit time to get going, but basically this is how it looks like when the vehicle moves. Okay, so if I think, yeah, that we have covered all the 4 different areas. As mentioned previously, Elastic Search is very good for geospatial queries. Basically, we have all the lat long related data, and Elasticsearch is very good. We can basically represent something called geodata based on the lat and long geopoint, and based on the geopoint, we can do complex aggregation. And as we have seen, it constantly collects telemetry data from the vehicle and driver safety score. So in real time, we can run analytics engine on top of Elasticsearch to consume that data and figure out further analytics for trip optimization. So as you keep on optimizing your fleet based on the trip timing of the trip, the mileage it had, and also based on the driver score. So if you combine all this data, then you can figure out where improvement is needed. And when the improvement is done, it can save trip time, it can save on gas usage or battery usage, and also it can save on the vehicle's condition, overall condition. The green grass is installed on top of FreeRTOS. And once it's installed and interfaced with vehicle's computer, the TCU, all the telemetry data that has been exposed by the vehicle's TCU to Greengrass will be able to consume those and push them over to IoT cloud on MQTT topics. So each at time of registration, the vehicle will get its own unique certificate ID. Using the certificate ID, it will get onboarded using those 5 REST APIs, right? It'll get onboarded on AWS IoT Core. And once that initial setup is done, then using the VIN number, the topic which contains the VIN number, each topic contains the VIN number, so it's unique for each vehicle. Using that topic, the vehicle will be, the car will be able to send all the telemetry data. So once the data is here for processing, there are multiple paths. So first way is to the IoT rule. So all of these are done using the rules that we have seen. So rules are nothing but as soon as data is available on a topic, the rule executes a query like SQL-like query to get the data out of that topic, and then sends it, one particular rule sends it to Kinesis Firehose, and another rule invokes a Lambda. So the one that sends it to Kinesis Firehose sends it to S3 bucket for raw telemetry. So we store it as a backup for future purpose, and then the other Kinesis Kinesis Fires also sends this data to data analytics, and data analytics uh, data has been is analyzed by data, then it's analyzed in analytics and sent it over to data streams, and through Lambda, it's written to DynamoDB. And DynamoDB streams are enabled through which it invokes a Lambda, and again, it ends up in Elasticsearch here. And this is the part that we have seen, API gateway. From API gateway, from Fleet Manager. Okay, we'll come back to Fleet Manager a little later. The second option is data is there in IoT Core, and then it invokes a Lambda. Lambda will calculate the trip. It will also calculate the trouble. It will also use the trouble codes and calculate the driver score and transform it according to the structure we have defined. And after transformation, those data will again end up in Elasticsearch. Here is our fleet management UI. Fleet management UI uses Cognito, the ID token that we have seen, and it is backed by CloudFront and also DNS. So as soon as we hit it through DNS, it reaches the CloudFront, and from there, using static website hosting on S3 bucket, the front end is hosted on S3 as a static website, and from there it verifies the authentication, it verifies the token, authorizes it, and if everything looks good, it comes to API gateway, and API gateway invokes Lambda, and Lambda talks to Elasticsearch and gets it queries on latest telemetry index to get the latest telemetry data for that vehicle. So here it all begins here. Here is the user. Here is where we are sitting, and as soon as we hit the URL, fleet management URL, it will ask us to sign in. The sign-in process is taken care by Cognito, and once it's done, it will forward the request back to API gateway and fetch all the details. And at the bottom, we have seen the connected CDF framework, connected device framework, where it takes care of certificate rotation. It takes care of the initial provisioning of the vehicle and also asset library. This is also part of CDF is the base, and CMS is running on top of CDF. And to talk to CDF framework, we have created a facade layer where we have again an API gateway which talks to Lambda, and we can in turn talk to the CDF framework. So this is overall the summary of the architecture that we have currently implemented.